Hello and welcome. So time has finally come to talk about machine learning. Now, before we try and go into the details of what is machine learning, I would say we should get an understanding of how do humans learn. So just think about it. Let's say when a baby is born, do you think a baby is able to distinguish between a cat, a dog, and a horse? No. How would a baby learn? So the baby will learn through a process where a baby will try to identify based on different features, right? So it can think of it like if it is having a long ear, black nose, then it could be a dog, right? If the eyes are specifically blue in color, and it's very small, then it could be a cat, right? So how are you learning, or how is a human learning? A human is just learning by examples. We normally say you could easily learn by examples, what you see all around. Then you could even see diagrams, or you can make some comparisons, right? So the same way a human or a baby is learning, same way we are making a machine to learn, right? Now you might ask, but how do you do that? So how would you do that? If I give you an example, now here, if I feed, say, thousands of photographs or of dog, cat, horse, and probably then label them as well, that if you have this kind of a feature, if your ear length is this, if your nose is like this, if your eyes are like this, then you are a cat. Otherwise, you are a dog or you're a horse. So I'm feeding, let's say, a lot of data to the computer. And based on that, I'm trying to identify the patterns out of it. And once I have identified the patterns, then I will train my algorithm. And once my model is ready, based on that algorithm, then any new data that comes in, it can make predictions for me, right? It can tell me based on these features, whether it's a cat, it's a dog, it's a horse, right? So theoretically, so machine learning is a branch of artificial intelligence. Now you might remember we discussed about the onion thing, right? The AI, ML, DL, right? So AI, ML, and DL. So ML or machine learning is a subset of artificial intelligence. Now this subset focuses on the usage of data and algorithms. Very important. Guys, if you ask me, what is the heart and soul of machine learning? I would say the heart and soul of machine learning is data. Very important. Your data needs is very important here, right? And you are focusing on the usage of data and algorithms. Now, we learned about algorithms. Algorithms are nothing but set of rules, right? Normally based on, say, statistical mathematical techniques as well. Now, machine learning is helping a machine to imitate or mimic the way that humans learn, gradually improving its accuracy, right? Perfect. As I told you, how would a baby or how would a human learn? You would look at examples and you will gradually improve your accuracy, right? So when you look at different examples, when you do comparisons, then you would be able to make out that yes, it is a cat, it is a dog, or a horse. So in machine learning, computers apply statistical learning techniques to automatically identify patterns in data. Very important. As I told you, statistics is nothing but it's the study and manipulation of data, including ways to gather, review, analyze, and draw conclusions out of your data, right? That's very important. And if you try and see this diagram, it clearly says that you have data and data contains patterns. Now, your algorithm is such that you need to find the patterns in the data, right? Let's say if I talk about the cat and dog example, there will be features, different features, right? You need to identify the patterns in those features. And you will actually train your algorithm based on this data, right? So once you've trained your algorithm, then you build a model. Very important. Once you have built your model, then any new data that comes in will be fed through that model, right? So this is normally, you can say this could be your, training data. So data is always divided into training data, and you can say it's more of like a testing data or test data, which will help to check the accuracy of that model. Don't worry, we'll actually talk about a more workflow of machine learning, in that you will see in more details. But for the moment, just understand data has got patterns. We are trying to find those patterns. We are trying to train our algorithm, right, using the training data. And once you have trained your algorithm, then you build a model out of it, right? And that model helps you anyways recognize patterns in the data. And once you have built a model, right, then you use new data. So you won't use the training data again. You will use testing data, which is separate. So testing data is fed into the model to give you predictions and descriptions. So let's say if I give few features, then it should be able to tell me that whether it is a cat, it is a dog, or it's a horse, right? That's what is the aim of machine learning. So as I said, these patterns are then used to create a data model that can make predictions, right? And with increased data and experience, the result of machine learning are more accurate. So as we said, how humans learn? Humans learn gradually, right? They improve upon their accuracy. Same way machine learning algorithms improve, right? Whatever say patterns it is finding out, you use the testing data and you improve upon your parameters, and you actually learn as you go along, right? And yes, there are three main approaches, and don't worry, we'll actually go deep dive into all of these. One is called the supervised learning, which is the learning from labeled data. So this example is a labeled data because I'm giving the features and I'm also telling if this is the feature, then it's a cat. If this is a feature, then it's a dog. So it's a kind of a labeled data. Then we have unsupervised learning. So supervised is where you are actually labeling your data. Unsupervised is where you don't have the labeled data and you have the unlabeled data. Very important. And unsupervised learning helps to identify patterns and structured in the unlabeled data. And we have another type which is called the reinforcement learning. So you keep on learning. We say that it is learning based on rewards or penalties. Again, I always give an example of a baby, right? A baby or a student, right? How do the teachers do? The teachers will always give you rewards if you do something good, but they'll also give you penalties, right? If you don't do something wrong, if you do something wrong, or if you're not on the right track. Same way, we are training our baby, we are training our machine, and this is based on reinforcement learning. Again, we'll go more deep dive into this. Don't worry about it. Very, 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 very important point. I always talk about the heart and soul of machine learning is data. Now, you might say data is fine, but two key factors in data, the quality and the quantity. So it heavily relies on data quality, because if you are giving garbage, if I'm giving garbage data here, I should expect my model to be garbage. As simple as that, right? So we need to spend some time doing data pre-processing. Very important. So data quality is very important. Again, the data quantity is important. You will see that your model or the accuracy of model will improve. Let's say if I have, let's say 100 things I'm feeding into this, and if I'm actually feeding 10,000, then you will obviously see that my model improves, right? So the data quantity is also important, right? Again, based on the example of cat and dog, if I'm feeding in let's say 100 rows, right, my model is getting trained, but I'm feeding 10,000 rows, then it's really getting a good understanding of patterns. This is the key here. You are trying to understand the patterns here, and based on that you can make predictions. And algorithms, as we already saw in previous lecture, algorithm is nothing but the set of rules, and they are normally based on the statistical mathematical techniques. Utilizes a variety of algorithms tailored to specific type of data and learning tasks. And yes, as we saw an example of machine learning in say Netflix, I already showed you, it is actually being applied in diverse fields. You can use machine learning in healthcare industry, in finance, especially if you have to do, say, fraud detection. Then it is being used for autonomous vehicles and also for tasks like prediction, classification, clustering, and deployment. So the trained models, like if I take example of this, let's say this is my trained model, right? Once my model is built, this is my trained models are deployed in real world applications to provide insights, automate the tasks, or even enhancing the decision making. So I think by now you've got a very good understanding of what is machine learning. So always remember that whenever somebody asks you machine learning, just think about the way humans learn. Or a baby, once a baby is born, how would the baby get trained? Same way we are training our machine, we are training our computer program based on the data we are getting. And very important points, data-centric machine learning heavily relies on quality of data and quantity of data. Thanks for watching.